So the last but definitely not least presentation of today will be done by Zeta Chrysafaki, Apostolos Mousourakis, and Dimitra Kada, of our partner at the Greenest Project, PILIKO. And they are going to show us, to present to us their activities in Crete mainly, but all over Greece, with lightweight clay and straw. Okay,
let's go. Kalispera to everybody. Thank you to be part of this workshop, Greenest workshop. We will have a presentation that will be in mainly two parts. The first part with Dimitra, the newest member of PILIKO, will speak to you about what we are doing, what is PILIKO, and what is maybe the future of PILIKO. After a small passage, Zeta will explain and present some project, real project, some houses and one school that we realized in island of Crete. So, Dimitra, come.
So, PILIKO is an urban non-profit company. Since 2006, works to promote and develop sustainable design based on the use of natural and recyclable materials. PILIKO belongs to a wide international network of organizations, and we collaborate with academic institutes, regions, and local companies. We try to connect academia with engineers and practitioners. And in Crete, where is our basis, we have a close collaboration with Technical University of Crete and the School of Architecture. We do workshops and visits on construction sites, so students can familiarize with earthen materials in a real project. The main aspects of the collective work of PILIKO and its members are divided into three areas: the education, the research, and clay building consultancy. Emphasis is placed on promoting clay architecture and construction through educational programs, workshops, lectures, exhibitions. An important part of our research is recording the Greek architectural heritage with clay, and at the same time modern architecture with natural materials. Our members that are architects, civil engineers, interior designers, also provide technical advice on the application of natural materials in architectural study, on design, and on construction site. Our team started the training from the first beginning of the team with workshops for both to educate and to be educated in different techniques on building with natural materials. We always invite experts to demonstrate their techniques, their local techniques. It's also a way to expand our network. This was also enhanced by, these are some photos from the workshops that we did over the years, different techniques, different local materials. Our team also travels a lot, and this is a way to enhance our knowledge, to see and training for both theoretical and on practical way. We have traveled exams here from Balkans, from Latin America. We also do many exhibitions, conferences, and lectures. Our first publication also was a result of our anniversary conference of 10 years of PILIKO, with examples of earthen architecture that were in the exhibition. Later, we organized our lifelong educational programs with, that is more than 50 hours, theoretical and practical, lessons in building with clay and construction techniques. We do all the techniques, so somebody can get familiarized with the natural materials. We also do fast labs, working with different natural and recyclable materials, such as clay, canes, wood, fabric. And we want also to evolve the design with natural materials and produce not only installation and more artistic structures, but also utilitarian objects. We always present the outcomes of the workshop at exhibitions open to public to share the results and to disseminate the knowledge. Also, especially during the pandemic and afterwards, we organized and participate in many online events, lectures. In recent years, we try to collaborate more with local communities and do our events there to enhance and promote local architecture and local materials. Over the years, we have participated in the writing of many scientific articles and papers, which you can find on our website, that we want to work as a tool. And we also participate in research programs. It is very important to disseminate our research to the public. This is the way why we participate also in fairs. Over the last 6 years, we have begun the documentation and recording of raw earth-based constructions all over Greece. Here is the areas, all these with the colors, the areas in Greece that we can find raw earth-based constructions. And we want to do some events in all these cities. And our first we began with the first event before 2 months ago in September, the municipality of Triphylia in Messinia, in Peloponnese region, an event that included a conference about wood and clay and earthen architecture on Balkans, an exhibition about local earthen architecture of the area and examples of Balkan earth architecture, and a 3-day workshop about the art of wattle and daub, designing and constructed an installation which will remain on the local folklore museum of Kyparissia. I'll give the Apostolos.
Okay, so for many years we involved in this galaxy of earth architecture, but we are working as freelancer architects. So we must have a proposal to our customers, and so we think a lot about this. We make research and we travel a lot along Greece, and we concentrate in a special technique that is wattle and daub in English, but or it's a timber frame practically. In Greece we call it, in Greek we call it xylopikto, and so we saw that the use of timber is very important in Greece from the prehistoric epoch. We speak, Eleftheria speak just before about the Minoan civilization, but we know that for example, the palace of Nestor in Peloponnesus, or the Cyclad civilization in Akrotiri, they had a huge using of the wood. And we discover all around in Greece that in the our heritage. A big part is with wood. So we have here two examples. One is the anti-seismic technique of Lefkada. Maybe most of you know about it. But another example is another wooden and earth constructions that we found traveling in the west part of Peloponnesos, especially in close to the city, in the city of Philiatra and Souther. And we are studying now this case. But we see that not only in Greece, but everywhere, you know very well, this technique is from the medieval epoch, and we have a lot of documents. Or, for example, we can find in the center of historic cities like here in Toulouse, multi-plan palaces with wooden construction, wooden and earth construction. But we have another movement last years with the system, the like clay system, that we try to give our proposals to concrete new buildings that Zeta now can describe you.
So we had the luck, I would say, in the last years to have some people that decided to build with these techniques. I have first of all to say that that people are not convinced that natural building with earth, and we are talking about building with earth and other rural materials. So in our Greek society, people are not convinced that they can use this material in order to create buildings. They are afraid. There is the conventional techniques with reinforced concrete and bricks that they are used to. So most of them, they prefer to follow this way of construction. And of course, we have seen all these years that it was quite impossible to convince any one of them to change their way. So our four experiences were with people that had already convinced themselves that in this way of building is right also for them, but also for the environment. So that's why I'm telling that we were very lucky, because all this work that we have done with PILIKO in the dissemination of earthen architecture and earthen techniques would be only romantic if we could not have these four buildings also for us going inside the procedure of issuing building permits and constructing real buildings with these materials, and also for our future perspectives that we would like this way of construction to be a future way also for the Greek country. These four buildings that we have constructed, three of them are residential buildings. The first of it, though, was the European Sustainability Academy. That was a building of 230 square meters used as a seminar hall that is built. That its permit was issued in 2009, and the construction finished in 2011. The second house was for a four-member family in Chania as well, with a building permit issued in 2012. That means in the new construction regulations of Greece that changed in 2011, and this construction was finished in 2014. A vacation residence for a 5-member family was created was studied and constructed inside a settlement of Chania and not in a rural area as the other 3 constructions. That was finished in 2017. Under this, you can see also the partners of ours, of us, during these constructions. And the last construction that we have implemented was in 2019, a 4-member family in Iraklion. And all the 4 buildings have been used since then. And I would now want to explain to you a little bit how was the construction technique that we have used in these buildings. All the 4 buildings are in a rural environment. As you see, they are all in Crete, so in a Mediterranean climate with very hot summers, with mild winters. In Dibaki, especially, what is the last one, it has even more hotter summers than the rest of us in Chania. And they were all studied and designed with bioclimatic principles. So this is important because the behavior of the buildings is not based only on the materials, but also on the design. So the main load-bearing structure of the 4, usually, this is me. Okay, foundations, okay. During our experience, we have seen that in order to be more close to the conventional constructions and also to come more mildly to the people, we cannot deny any conventional way of construction. So our foundations are always from reinforced concrete. We use the reinforced concrete because it is also for our statistical engineers to do the studies, and because many times we were asked to do, for example, stone foundations, but our engineers, our collaborators could not be sure that we could also then receive a building permit. So the foundations are usually, as I said, from reinforced concrete. On this foundation, there are these metal junctions that will last and combine the foundations with the rest of the construction. And here is the first step of this particular regulations that we need for the natural buildings. That means which are to avoid the rising humidity from the ground to rise and go to our wall. So mostly on the top of these foundations we have a sealing membrane. So as well the timber frame structure, also the wall from earth and rural materials is not hazarded from the ground. Main load-bearing systems are used in our constructions from a timber frame. Here we have depending on the technique that we use, different also solutions. The first 3 pictures that you see on the left are constructions that are structures that have to that are going to receive a light clay construction technique later. The one here on the right was a structure that would be embraced from straw bales. We have to say that usually the wood that we use is glue laminated timber frame, because first, if we need certificated wood from recycled wood, we can only have it in glulam, at least in our country. And secondly, because only in glulam wood we can find specifications about the load that can have these constructions. Natural wood in Greece is not available easily with specifications that can be used from the civil engineer in order to solve and do the study for the structure. Here you can see different ways of and philosophy of the statical study. Every civil engineer has his own way of thinking of how this structure has to behave. So we have the experience of Eleftheria, for example, as you see in the four pictures on the left, where we have a model. In this model, we have Eleftheria has come to the final decisions that all this wood can be of small dimensions. We can have metal junctions that are not for every junction different, but we can have one and applied in all these corners. And of course, easily like a Lego, which means that this makes the whole construction more easy and quicker to be finished. Other experiences that we have from other civil engineers are more, so to say, probably also conservative, I would say. Probably because civil engineers do not know so much how the wood is behaving in the earthquakes, or they don't know it very well because most of them are being used in resolving constructions of reinforced concrete. So they give a more oversized dimensions for the wood in order to be sure that this is going to behave well. This main construction for our techniques uses a secondary non-load-bearing frame, which mostly is constructed from natural wood in smaller dimensions. This has two roles, and this secondary frame is being studied in an early stage of the project because it has to do with the mold that we are going to use after for the construction of the walls, and also because on this secondary frame we can put all the electrical net that can be put in the right position also before the construction of the walls. This helps us gain a lot of time and a lot of also of money because we have a very clean site, and then we can put this plastic rollers, how is it called, inside our wall during constructing our walls. The non-load-bearing construction techniques that we use are with nature-based materials and rural waste. Nature-based materials now we somehow define the earth, because we use earth, and also the line, because all the techniques that we describe have to build one system that has the possibility to respire, to breathe. Okay, so during these constructions, we do not use cement-based or other industrial-based plastering or other materials in our walls. External non-load-bearing masonry we have used with straw bales, whole straw bales, taken directly from the land. These techniques are not very easy, particularly for us, because we cannot build load-bearing walls from straws, which means that we have to have columns. If these columns are inside our walls, we have to cut the straw, and this is our case. So we had to cut the straw, to rebind it, to find the right way to put it inside our walls, to have wooden beams to press them in order to make them stable between the columns. And of course, after this, we had to assure that also the finishing of the top was in a easy and in a right position of the walls, because usually the load-bearing construction from straw bales, the straw bales are being built till the top, and then they are stressed so that they can be stabilized. In our walls, usually we have to have first the frame and then to put the non-load-bearing construction. During this construction, we had also a workshop, and this is important also for us, but also for the people around, to be able to see the constructions, to participate, many of them, and also to give the knowledge on and forth to other engineers and architects that they want to use it. So the light clay technique, that is the technique that we use mostly in our constructions, is the technique that we have realized that is more satisfactory, more satisfying,
Convenient.
yes, and convenient and right for our climate. The technique is an old technique, and here you can see also some pictures of the light earth building book from Franz Volhard. This is a technique that was in the 1944 and 45. Light straw clay, fiber clay. Well, light clay means that I have earth, and inside I put material that that creates a mixture that in a dry density we have 1,200 till sorry, I think that this is not. No.
300.
Yes, 300. No, here I had a mistake. Sorry. It's from 300. Oh, just a minute. Stroke laser. No, light clay. Yes, light clay. Means that I have a bulk density of less than 1,200 kilograms per cubic meter. That means that we can have a light clay and a medium pumice category, which is even less, which means between 600 and 800 kilograms per cubic meter, and very light mix of 300 kilograms per cubic meter. This means that I have less portion of clay and more portion of straw. Before we decide the mixture that we want to use, we do some tests in order to see if our clay is right. So, which means that we need a clay that it has a lot of. We need an earth that has a lot of argile, of clay, and we do some bricks. We weight them in order to see how heavy is our mixture and how heavy we want to reach our mixture. Here on the right you can see also as the side, again from the book from Franz Volhard, how is the side of this light clay. The first thing that we do is to cut the straw. The second one is that we have to put the earth inside the water, because by using the water we have the possibility to have a very thin and a material which is workable, yes, but also to liquid. And because also the earth has this possibility to get more strength, more powerful when it is stayed inside the water for more time. This has to do with the fine parts of clay. So this is a very important stage of the construction. And then we mix this liquid earth together with the straw. We put a mold outside of our construction, of our load-bearing construction, and then all the material is putting inside and rammed with some wood. Here we see how somehow in Greece we have, okay, we don't have particular regulations, okay, but inside the technical instructions of the technical chamber in Greece, there are mentioned adobe bricks, which are thick, and adobe bricks with the mixture with straw. And they say, and they give us some numbers about the L. The L value, yes, the thermal conductivity, which is important in order to calculate also the thermal behavior of the building. Down you can see the DIN standard for the same materials. So we are very close, even if we don't have regulation, at least we can use it, we can use these technical instructions to build and to have issues, permit issues, permit buildings. So the construction site, here you can see some photos. Every time we create some new tools. Yeah? We can work on hand, we can work on tables, we can also create some new machines, as these barrels that you see there, where they have inside some radius, and we put inside the earth and the straw, and they mix it. On the center you can see how these molds are being put, and the workers are putting inside this material. And on the right side you can see this facade. During this procedure you don't need to wait a lot till you bring the mold from down to upper stages. Just when you feel it in the first row, you take it off and you put it up, which means that this helps to do the works quickly. The production of adobe bricks with earth is a technique that we also use inside our constructions, mostly for internal walls. This helps us a lot maintain as well the temperature inside when we have the winter and the high temperature, so we arise a little bit also the thermal behavior of the building. So we had the opportunity in 2022 to do monitoring in this in the 3 of the 4 buildings that we have built with Professor Denia Kolokotsa from the Technical University of Crete, a Professor Isaac Meir from the Ben Gurion University of the Negev, and a physician who was doing his PhD in the university. We measured external temperature, internal temperature, relative humidity, ventilation infiltration, and thermal comfort analysis for the 3 buildings. Here you can see all the characteristics of the buildings that we had to study and to give in order to do the comparison. And here are our results. On the left side you can see the outdoor temperatures in a cold day, in a mid-season day, and a hot day for the 3 places that we are. They are mostly in the same level of temperature. In the second column you can see the indoor temperature. On the first the house in Drapanos. We have an external temperature in a winter period that you can see with the yellow line, and inside we have the most stable inflation of the graphic. Bravo. Τέλειο αυτό. Πού το? Good. Yes. Here in Bafes, that was in the autumn period. Again, you see the external temperature outside and the internal temperature inside our buildings. As well here in the Nyochorio summer period, with mostly over also 40 degrees external temperatures, and inside we didn't reach not even the 28 degrees of the buildings. And I have to say that these buildings do not have an air conditioning. They have only one stova, πώς είναι η στόβα, ένα σόμπα ή στόβα, or τζάκι. Fireplace. Good. Or a fireplace. And they have these results only from the construction of this, by using these techniques. The relative humidity, which is a very important factor in how somebody feels inside the building, you see the same thing. In Drapanos, in winter period, we have very high moving of the external humidity. Inside, we have a stable environment. The same in Bafes, you can see that here. The same in Nyochorio, this is the external and this is the internal. These results were published in a scientific, in Elsevier. And of course, this is a very important step for us, because we have somehow tried and we have reached to show that we have very satisfactory results of these buildings in Crete, in Mediterranean climates, because this is a very important thing, and that they can reach the sustainability standards and even more pass them probably in the future.
Okay. So practically we used to these buildings wood, straw, earth, and a little lime for the outside last level of plaster. So we have, I think we have a good experience now, and we can tell about the environmental benefits, like low energy consumption during the construction and during all the life of the building. Eco-friendly materials and techniques for the builders and the users. So it's a very safe and friendly technique that, and this is the reason that soon the owner involved in the construction. Easy recyclability of the building materials, and everybody can understand that at the end of the life we can recycle all the materials. And contemporary, we have a flexible architectural design. We can make architecture. This is very important for architects. About the socioeconomic benefits, is a completely different concept to the economic working of this construction. Favorite the circular and the local economy. We can involve a lot of persons from the place and work there. The economic distribution changed, so from we have a lot of day working ergatores, working hours, instead of expensive construction materials. So we use the local workforce and the local techniques soon. And at least these buildings require a low maintenance cost, have a low maintenance cost. So we can tell that we have the opportunity, a big opportunity inside the greenest program to go on and to check a number of perspectives, like the applicability of environmental, mechanical, and digital technologies, the possibility of standardization of construction phases. That is something very difficult for us. Instead, with a program, a European program, important like the greenest is very possible. It's a possibility to apply alternative natural eco-materials, different vegetable fibers, animal residues, and other recyclable materials. Another perspective is the evolution of the professional specialization. We know to us, like architects, very soon we have to work like craftsmen on these buildings, and this changes the nature of the architectural professionality. Okay. Okay. Sorry for our difficulties to the English language, but.